The coordinator, Nakiran, shall we start?
Sir, yes, sir. Shall we start, sir?
Yeah, I think it's 2:31. We can just begin. We can see roughly around 42 persons will join. Okay, good afternoon to all the participants, respected faculty members from various institute, research scholars, my colleagues, uh, various MTech students for joining us on this day two of this FDP titled Advances in Intelligent Civil Engineering, that is AICE 2025. So today is day two and the session two. It will be handled by Dr. Arkopal Kishore Goswami from IIT Kharagpur. So let me just take this opportunity to give a brief introduction about today's speaker. It actually gives me a great honor to introduce Dr. Arkopal Kishore Goswami, the chairperson and associate professor at Ranbir and Chitragupta School of Infrastructure Design and Management, IIT Kharagpur. Dr. Goswami is a globally recognized expert in urban mobility, transport analytics, and sustainable infrastructure planning. With a PhD in civil engineering from the University of Virginia, USA, and over 15 years of experience across India, the US, Germany, and Japan, he brings a rich interdisciplinary perspective to the future of urban transport. He leads the multimodal urban sustainable transport, that is MUST research group at IIT Kharagpur, and has spearheaded projects like SUFFER, that is a AI-driven road safety, then TOTEM, that is a ADB funded emissions modeling, and SPARK, that is land use transport emissions modeling with the University of Leeds. His work is not only academically rigorous, but also deeply policy relevant, shaping conversations around transport electrification, equity, and climate resilience. Today, Dr. Goswami will walk us through the transformative role of urban transport electrification in building a smarter, cleaner, and more inclusive cities. Please join me in extending a warm virtual welcome to Dr. Arkopal Kishore Goswami. Thank you, sir. Thank you for your valuable time for us. I'll hand over the session to you. Again.
Thank you. Thank you so much, Dr. Priyam. And thank you to everyone at the Madanballi Institute for organizing this wonderful faculty development program and inviting me to this program. I'm really happy to be amongst you. For those who are, the participants, for those who are from Andhra, I should let you know that I also grew up in Andhra in Guntur. So namaskaram andariki. Naaku inka konచెం Telugu vachu. That means I still know a little bit of Telugu. So, but I will be mostly lecturing or giving you the lecture in English. It's not really a lecture, it's my experience over the last 20 years being in this field of urban mobility, which I would like to share with you and possibly at the end also discuss a few things with you. And I hope that beyond today we'll still remain in touch so that we can, possibly work together in the future. Let me try and share my screen now. And let's hope this works wonderfully. Are you guys able to see the screen?
Yes, sir. It's visible, sir.
Okay. Let me make it full screen. Okay, is it visible on the full screen mode?
No, sir, it is not come into the full screen mode.
Now?
Yeah, now it is visible, sir. Now it is visible.
Oh, okay, wonderful. So thank you so much once again for the warm introduction and welcome everybody to this session, which is for 2 hours. I don't intend to speak all the 2 hours. we will, have some discussions also, hopefully, and that will make the session a little bit more lively. As introduced, I'm R. Gopal Goswami. I'm currently an associate professor and also chairing the School of Infrastructure Design and Management here at IIT Kharagpur. And today I'd like to discuss with you all a very burning topic which all of us face almost every day, which is of transport and environment, and how we are facing this acute problem of growing energy needs and growing environmental issues, which are leading to health problems now because of prolonged exposure to the pollutants. And a large part of those pollutants come from various transport modes or the transport sector as a whole. So what is happening? How are we monitoring them? How are we measuring them? What are some of the challenges in reducing those emissions? And how is India and the world looking to tackle these problems? Is some of the with some examples I'm going to discuss with you all today. So this is kind of the overview. What I'll try to do in the first half an hour, 20 minutes or so, is to give you an understanding of the urban transport scenario as a whole, and then get into some of the projects that we have been working here at IIT Kharagpur, where we are trying to, monitor or continuously monitor emissions using remote sensing techniques, using sensors, portable sensors, etc., and also how we are looking at improving the emission scenario by understanding how electric vehicles work, how they can be adopted in a more sustainable fashion in order to bring about a complete decarbonization of the sector, not just reduction in tailpipe emissions. So we'll get into a little bit of understanding of electric vehicles and its demand and how that can help in reducing emissions. And then finally wrap it up with some of the ongoing research regarding which we'll give you a little bit of glimpse and possibly also suggest some way forward based on those ongoing research that we are handling today. Hopefully this will be informative for all of you, and maybe, like I said, we can also work together in the future if anybody of you is interested in this field. So just as an introduction, I am a civil engineer, but over the years, over the last 20 or so years, I have kind of developed a niche in the area of multimodal urban transportation systems. So as you know, as an undergrad, we are all civil engineers, but then, we are either civil engineers or urban planners who are learning a little bit of transport planning. Then we kind of do a master's program, which is a little bit more intensive, and we kind of tend to focus in transportation engineering, where that also has many couple of branches where you either get into pavement engineering or then traffic engineering, or then you get into kind of transport planning. Even for the undergrads who are bachelors in architecture or urban planning, they too kind of have some master's program in city planning and so on and so forth. And then because of my work in the industry prior to my academic job was mostly in the urban transport sector. So when I decided to come up and teach, I decided that that should be something that I should focus my research and teaching on. So mostly I work in the area of multimodal urban transport systems currently. And what is that? And what is multimodal urban transport systems? If you look at that, I mean, urban surface transport, I mostly deal with modes of transport that are on the surface, I mean, that runs on roads. So urban transport can also nowadays include, water metros. But I don't deal with them a whole lot. And also, the modern way of transportation is looking at urban air taxis or even, hyperloops, which I have not gotten into yet, or my expertise is not in those fields. So mostly what I'm looking at is urban surface transport, multimodal urban surface transport systems. And it is an amalgamation of all of these various domains. So it is purely multidisciplinary in nature, where a student working at any problem at any given point in time has to have at least knowledge of two, if not three of these sectors, right? You have to at least understand road design, you have to understand data analytics, you have to understand urban planning and land use. Along with that, if you are interested, you need to understand user travel behavior, economics and econometrics, environmental sciences, which today's topic is relevant to, and all the information technology and infrastructure management. So, there are so many branches, there are so many expertise that you need to be solving any of the urban transport problems. That makes it very challenging. That's why are constantly looking for specialized personnel in this field. So when we develop even curriculum, we keep this in mind that somebody who is graduating out of our institutes are at least well versed in 2 or 3 of these domain areas, so that they can solve a urban transport problem holistically. Now, to give you an overview of urban transport and sustainability, right? Sustainability is something that we cannot shy away from anymore. Any systems that you talk about, you have to think in terms of sustainability. But if you start looking at the urban transport scenario, you will see that there's a lot of unsustainability that is happening in India currently. Our motorization rate is growing at an alarming pace. The number of accidents on our roads is also growing at a similarly alarming pace, and the emissions are increasing day by day. So all this trifecta of events are happening, which is leading to a lot of issues or externalities of in the urban transport scenario, where we see every day there are long traffic jams in metropolitan areas, or there is very poor infrastructure degradation happening even in smaller towns and cities. And of course, when we talk about affordability, we see that the people who cannot afford expensive cars are left to tend with public transportation, which is not being upgraded, which is in poor condition, and over-congested systems. So affordability is going down, and equity is not being maintained. So people are when projects are being planned, they are heavily focused on motorized vehicles, ignoring mostly improvements in the non-motorized sector, such as pedestrian and bicycle improvements. And hence what happens is all the benefits of these large projects are towards car owners, who are usually well-to-do, wealthy people, and hence the equity becomes a problem where a project is not solving. A project is then looked upon as not solving the issues of the poor, but only looking at a certain section of society. So, all of these things put together, we are seeing a lot of unsustainability that is happening in India. And what I see is a cycle in which our cities are currently stuck at. Right? If you look at this cycle, you will see that some of the things are an input to this cycle. Of course, input to transportation, which we cannot control, such as population growth and concentration of jobs in cities, right? There's a lot of population growth happening and many jobs being in the cities. A lot of people are migrating to cities, right? That is nothing that transportation engineers, planners can control. I mean, there's very little we can do in order to control that. As a result of people having now suddenly moved to the city and having relatively better paying jobs, their income, their household income is increasing. As the income increases, the first thing people think about is to own a motorized vehicle. It may be a motorized two-wheeler or it may be a motorized four-wheeler. So now you have people who have moved to the cities and are starting to own more and more vehicles, which is now leading to the cities' transport infrastructure being stressed. Right, most of our cities are old. They do not have sufficient road network, and even if they have sufficient road network, the quality is very poor. On top of it, when this additional number of vehicles are starting to ply, there's a lot of stress on these transport infrastructure. And then once the transport infrastructure starts to crumble, people start complaining that there are too many potholes, this, that, and the other, and then the government starts investing heavily in either increasing road capacity to reduce congestion or to build flyovers, etc. in cities, which is thought to be a solution to reduce travel time in urban areas. So there's heavy public investment in roadway capacity improvement. So we always think that if there is congestion, let us expand roads. That will give us a solution. But as the road starts expanding throughout the city's network, people start now living farther and farther away from the city center. They see good road connectivity, and good road connectivity leads to reduced travel time. So people start thinking that why should I live in a congested city? Let me start living a little bit farther out. So the suburban areas start encroaching onto farmlands, and the phenomenon of urban sprawl starts to take place. As people start living further and further away, what happens is, your demand for public transport reduces, because as we know, public transport works best when there is high density, and the suburban areas have very low density. So being low dense areas, public transport does not work very well, and hence its demand decreases. And anyways, these people who are living now farther and farther away, everybody has a vehicle that they own. So now they can use that vehicle and start traveling. So now, leading from in addition to urban sprawl, there's also this additional effect of reduction in public transport. That leads to long-term behavioral shift from public vehicles to personal vehicles. This shift happens over long time, but once this shift happens, it is very difficult to reverse this phenomenon. India usually otherwise used to be a country or city of public transport. You used to see a lot of buses, and a lot of people used to move in buses. A lot of people used to move in local trains, etc. But this phenomenon is creating a shift in behavior from public to personal vehicles. This, of course, now that the personal vehicles are increasing, is again leading to an increase in congestion. So what is likely to happen again is this congestion is likely to again put additional stress on the city's transport infrastructure, and this cycle is kind of going to go on and on and on. There is no stopping it. So what experts say is one of the ways to do it is to not invest heavily in road capacity augmentation. Do not just widen roads. Widening roads is not a solution for reducing congestion or reducing emissions on the streets. So there's many cities now that's why heavily investing in mass rapid transit systems like metros and LRT systems and other alternative public transport systems rather than widening roads, because they are not seeing the benefit of reduced congestion. So somewhere along the line, every city has to think about this. Same things graphically, if you look, there's so much urban rural population that is migrating. If you start looking at imagery of your cities, just pick any city that you are living in, and if you start looking at the land use patterns over decades, you will see that the city is urbanizing. So this is the city of Kolkata. You will see that the red was the urban area back in 1991, but in 2017, the red has increased so much. So you'll see that there's so many people. Because of the influx of people from surrounding areas, the city starts sprawling. As the city starts sprawling, the GDP improves. As urban areas are the engines of GDP growth. GDP increases. People have disposable income. You start looking at the number of cars registered. That is increasing exponentially. And if you start looking also at the borrowing rate, is getting cheaper and cheaper and easier to buy a car, because nobody pays full to buy a car, but they pay it at, they purchase it at EMI. So the EMIs are getting lucrative over the years as well. And so a lot of people are owning these cars. And like I said, the bus fleet is reducing over the years, which is giving rise to now our cities being listed on the world's worst congested cities for 5-6 years in a row. This never used to happen, where many cities from India are being listed as one of the most congested cities across the world. So not just Asia, but across the world. We are now, this is from 2020 when it was first reported that Bangalore was, one of the worst affected, or one of the most congested cities in the world, along with New Delhi and Pune and Mumbai. But over the years, over the last 5 years, some of these cities have consistently been on the top 10 list. Some have been added. For example, Kolkata last year got added to this list. So, it goes on and on. And this is leading to, of course, not just accidents, but also a lot of, particulate matter emissions in our cities. Our cities during winters are becoming gas chambers. You cannot get out. You cannot breathe properly. The young are having a lot of, pulmonary diseases. The elderly are not able to breathe properly. So this is a epidemic of gigantic proportions that is taking place in India. The motorization rate, like I said, but the alarming thing is if you look at the rate of motorization, for every 1,000 inhabitants, we still have only 33 motor vehicles. So that's very low number of motor vehicles per 1,000 population. However, if we look at our growth rate, it is one of the largest in any of the regions. Our growth rate is 10%. So it's almost, China is 14% and Vietnam is 17%. So we are in those rates. So this Asia, Southeast Asia, East Asia is where the majority of the growth in vehicles is happening. So even if today we are grappling with this environmental and congestion issues with just 33 vehicles per 1,000 inhabitants, imagine when we reach these kind of numbers. So this is Europe, where half of the inhabitants have a motorized vehicle, whereas we just are at a number 33 and we are still struggling. So we have to take preventative measures right away so that we don't reach a stage where Europe or America is at. Another very interesting graphic, if you see, is the relationship between transport-related energy consumption on y-axis and urban density on the x-axis. So that tells you the transport energy scenario in India versus the rest of the world. So this is transport-related energy consumption, meaning any kind of energy that is required for any mode of transport in any city. So what you would see is that cities that have very low density, right? This is urban density is inhabitants per hectare. So cities that have very low density have very large transport-related energy consumption. What does it mean again? It means the same thing, that I was mentioning a couple of slides ago, is that when you live in a sprawled environment, you have to use your personal vehicle a lot. Public transport becomes infeasible because of low density. So hence you are using your personal modes of transport very, very much. So if you see here, you will see all the North American cities are notorious for this kind of land use transport patterns, right? Houston, Phoenix, Detroit. These are all cities that have seen huge amounts of sprawl over the years, over decades. And now if you see that their energy related consumption, transport related energy consumptions are very, very, very high. If you come down the curve, you will see that as density increases even by a little bit. So some of the Australian cities, although not all of them are highly dense, but some of them are a little bit more denser than the North American cities, so their energy consumptions are much lower. If you come even further down, you'll see the European cities, which are much more dense, and hence their energy consumptions are even low. Even further down, if you look at some of the Asian cities like Tokyo, Singapore, and Hong Kong, which have very high densities, urban densities, their transport-related energy consumptions are very low. And of course, this study did not include the Indian cities, but if you just overlay the population density or urban density of two of the most populated cities in India, which is Kolkata and Mumbai, you should be able to predict that our transport-related energy consumption. What should be our transport-related energy consumptions? But if you keep tracking them, you will see that they are not where they should be as per this world curve. We are actually a little bit higher than the world curve because now our density is, Kolkata is no longer Kolkata, it's Kolkata Metropolitan Development Authority. So it's the KMDA. Mumbai is just not Mumbai, but it's Greater Mumbai and everything else. So as cities sprawl, their density starts decreasing and their energies start transport-related energy consumption increases. Again, we have to remember that energy is not abundantly available, or is not something that is going to be remaining the same over decades or centuries. We have to be very mindful as to how much energy we consume and how much we leave for generations to come. So all of this leads to our today's topic of transport and environment, where we now see that in the emission scenario, the transport sector is one of the most poorly placed sectors. When you look at different economic sectors, you will see that transport is playing a big role in emissions. Apart from, you start looking the electricity and heat production and manufacturing sector. Right after these two sectors, you have these 22%, which is coming from the transport sector. So transport sector is almost responsible for 1/5 of the carbon dioxide emissions. And this is where we come in, and this is where we have to be very careful as to how we can develop strategies that is going to help us reduce this 22% figure. This is a worldwide figure. Now, if you further get into different modes of transportation, you will see that personal vehicles, within this 22%, personal vehicles result in 40% of those emissions that are coming out, and trucks and light motor vehicles are 34%. So both of them put together, the surface transport sector, almost is about 74-75% of the emissions that is coming out of the transport sector. So when we are dealing with cars in our cities, when we are dealing with commercial goods vehicles in our cities, we have to be very mindful as to how we can decarbonize them, how we can continuously monitor their emissions, improve their improve the quality of mechanical equipment that is present in the vehicles, and also at the same time look at decarbonizing these vehicles. And like I said, as a result of that, every 8th death in India is now related to air pollution. It has become an epidemic almost now to a very large proportion where, especially during winter months, you see that the AQI, if you just open any news channel or read any newspaper, you will see that, every urban area, which we had never heard of even when we were growing up, or even 10 years ago, is now polluted. And air pollution is one of the major, pollutants amongst them. This is again a snapshot. If you look at a calendar year, it shows Delhi's particulate matter PM 2.5, and you see that it is only during these monsoon months when you see a lot of green. Anything other than these monsoon months, you start seeing orange, red, and as you get into kind of the winter season, December, January, February, there's a lot of poor air quality leading up to almost April and May, the peak summer months as well. So many days are way above the WHO limits that are prescribed, and it becomes very, very harmful to citizens of various age groups, vulnerable people who are do not have a proper home to live in the urban areas, who are homeless, living in shelters, etc. They are even more vulnerable, but also are vulnerable to people who are outdoors. If you remain outdoors for long periods of time, if your exposure is high, you are now having these irritable eyes, you have a lot of sneezing, you have a lot of if you have asthma, you are really advised not to go out. So all of this is affecting our health, and health is affecting eventually the productivity. If you look at it in that terms, if you want to look at it and tie it up to GDP, then you can see that all of this is eventually having an effect on the GDP of the country as well. As such, India and many other countries are now starting to heavily invest in sustainable modes of transport. Like I said, metro rails have been there in India for a long period of time. Kolkata was the first one to get metro rail. Nowadays, many cities are investing in that. But at the same time, metro rail is not an answer to all the cities. So there are many cities that are also looking at, examples such as water metros, examples such as, monorail, examples such as BRT. So a lot of BRT is bus rapid transit. So a lot of such, mass transit investments are being made so that the intent is to not only decongest the roads, but also to improve the environment or reduce the vehicle-related emissions. These are examples of BRT, and as a part of that, electric vehicles come in, where now the tailpipe emissions can be completely or almost 99% reduced when you are using an electric vehicle. And we'll get into electric vehicles a bit more during the remaining part of our presentation. There are other modes of transport that are also getting a lot of attention now, or at least getting some reasonable amount of attention, which is improving the bicycling in many of the cities, improving pedestrian infrastructure in many of the cities, and also some examples of flexible work schedules, carpooling, etc., are also being implemented or being experimented with when it comes to large employers, especially. They are encouraged that their employee force should be, either they should carpool or try to reduce their travel to office every day by having a flexible work schedule. Maybe come into office 3 days a week, and the rest 2 days can be work from home or something like that, which eventually ends up helping the traffic congestion and traffic environment situation. Congestion pricing is something that India has not yet successfully come up with a policy of, but many of the cities around the world which have faced a lot of transport or urban transport related issues have tried out congestion pricing, which is to say that if you are using your personal vehicle, and if you are using your personal vehicle and driving it alone, then you will have to pay an additional toll when you use it during peak hours, because peak hours are already congested. Peak hours are already a lot of emissions happening on the roads, and you as a individual are adding to that emission, are adding to that worsening situation, and hence you are being asked to pay the price for using the road during that period of time. This has helped many of the other cities in the world reduce the number of personal vehicle users as they then shift to public transportation, and in that way helps reduce congestion as well as improve air quality. In India, you will see that there is a lot of monitoring and mitigation programs that have been introduced over the years. We have our emission standards for every vehicle that is set up by the Automotive Research Association of India, ARAI, which tells you that how much emissions are going to come out of which type of engine, which type of vehicle, etc. So all the manufacturers have to follow these standards, and then of course when the vehicle starts getting older and older, you have to get your pollution under control certificate, PUC certification, every year or every 6 months, so that it can be confirmed that your vehicle is still not polluting heavily on the roads. Such kind of systems are in place. There has been improvement in the fuel technologies. Now we are at BS6. We have jumped from BS4 to BS6, which has reduced the content of nitrous oxides, etc., in the fuel, and hence we don't see those black fumes that we used to see a lot coming out of, say, for example, heavy vehicles in our cities, trucks, etc. Now that has reduced to a large extent. And also, of course, you have your multiple schemes that have come out in India for introducing electric vehicles and encouraging electric vehicles, where each of the states have their own policies in order to encourage electric two-wheelers. So multiple strategies are being used. No one strategy can kind of help the situation. We have to use a combination of strategies. Now, if you look at the first situation, which is the tailpipe emissions, we know the basics of tailpipe emissions. We know that what are the different kinds of pollutants that come out of our engines, ICE vehicle engines, and we have these different kinds of models based on average speed, based on drive mode, etc., that allows you to not only estimate the emissions, but you have tailpipe sensors that can be put that allows you to actually measure how much emissions are coming out of your vehicles, which are usually used in your PUC centers. But what is happening more and more now is we need there is a need to continuously monitor, not just monitor when the vehicle comes to a PUC center, but also continuously monitor emissions when the vehicle is being run in actual conditions on the road, right? That is the need of the hour, so that because emissions happens on the road, if we can catch and understand which vehicle is emitting more, that is when we can enforce some stricter laws, etc. So in that sense, there has been experiments, and there have been on-field testing of remote sensing technology to understand how which vehicle is emitting poorly or performing poorly in terms of emissions on the streets. In Kolkata, there was experiments carried out by the transport department where vehicles on the roads were channelized, and several air quality monitoring devices were put alongside these road channels, and a video camera was also kind of put there to catch the license plate of the vehicle. So this is supposed to remotely sense how much tailpipe emissions is coming out of it. Of course, these have to be repeated over and over again so as to get the accuracy high. But nevertheless, this allows you to monitor a large volume of vehicles and their emissions while they are on the road. You also have your PEMS, portable emission measuring systems, that can be installed within the vehicles, and while you are driving, it gives you the emissions coming out based on your acceleration, deceleration patterns, etc. So there are different ways, there are different monitoring techniques that are now being utilized or tried out or researched in order to better understand what is happening to the emissions coming out. We cannot wait for the entire fleet to be electrified and not do anything at this point in time, right? Electrification will probably eventually happen, but the damage would have been done in the next 20-25 years when if we don't continue to monitor the condition or working conditions of the ICE engines, ICE engine vehicles as well. So we did a similar kind of a study to understand how to remotely monitor or remotely capture the emissions or tailpipe emissions coming out of a vehicular stream. So we were not interested much to understand the individual vehicles, because we were not trying. Our aim was to not punish the person. Our aim was to figure out in an area or in an intersection what is the air quality, what is the air quality measurement, and how much is that air quality responsible because of transport vehicles. So because as you understand, in an intersection, there may be many other types of land uses, such as, we have our street side vendors, we have, restaurants, we have many other point sources of pollution. But what we wanted to, understand was what is the extent of the air quality to which the transport vehicles are responsible for. So we did a similar setup with our devices as well, with the emission device and the camera setup alongside the road. And we monitored, at 3 different places, close to the intersection or at the intersection, after the intersection, and while at mid-block, which means that the speeds here were higher. At the intersection would have meant that the vehicles were stopped, so there was no movement of vehicles, whereas after the intersection would have meant that vehicles are still accelerating. So we were trying to kind of differentiate the air quality, or to differentiate the emissions based on where the vehicles were in relation to the intersection. Again, these these are a lot of and these are published papers. You are welcome to study the entire paper, or if you drop me an email, I can send you the papers as well. We found that there was good correlation when it comes to carbon monoxide concentrations and the morning peak time of vehicles, whereas the correlation was not that great during the evening peak, or maybe we thought 5 o'clock to 7 o'clock was the peak. Maybe the peak is a little bit later in those cities. So, however, we have 24/7 data. We have a full 24 hours data for this. So this tells us that emissions or pollutants does have a relationship with the vehicular volume. So this is the vehicular volume every 3 minutes, as you can see. and pretty much the pollutant concentrations are peaking when the number of volumes, when the vehicular volume is also peaking. So there is relationship, and hence we can, at least at a planning level or at an policy level, we can monitor such areas which are highly polluted in our cities and target those areas for some strategic interventions. We did a multiple regression of carbon monoxide concentrations against different variables, and of course you could see that heavy vehicles had the role of heavy vehicles was very high in the pollutant concentrations, whereas cars, two-wheelers and three-wheelers were very less, and followed by the heavy vehicles, it is the impact of cars is also pretty high. And also the rest of them are time of the day, location, whether it's mid-block or after intersection, so on and so forth. And we got a decent regression coefficient for that as well. So we developed these spatiotemporal maps as well, which helped us understand the differences in emissions when it comes to a collector stretch versus an arterial road. Collector roads usually do not have high volume of vehicles, hence you'll see that emissions are still in the green stage, whereas as you get in the arterial stretch and as you start getting away from the intersection, as the speeds start increasing, the emissions start increasing as well. Whereas closer to the intersections, as the speeds are low, the emissions are low. So this also tells us that all the land uses that are closer to intersections are very vulnerable, and they are exposed to such poor air quality throughout the daytime when they are doing business or when they are, whatever they are doing, whatever activity is going on there, they are likely to be very badly hampered. If you read the paper more, you will see that we have done inhaled dose calculations as well. Inhaled dose is, once you are exposed to this, if you are walking and you're exposed, it would mean that you are inhaling a larger amount of dose, because walking requires a lot of energy, and when you are walking, you usually start breathing heavy, and when you're breathing heavy, you are usually inhaling larger doses of the pollutants. So inhaled dose calculations is another step that we did beyond this to understand, if you are a pedestrian, how much vulnerable are you? If you are in a two-wheeler, how much vulnerable are you? If you are in a three-wheeler, what is your vulnerability, etc., etc. So it gives it's a lot of health issues that have shown up. I can tell you, we also did another study which is currently being published or not yet published, where we looked at how auto rickshaw drivers who are now constantly in the traffic throughout the day, and how their health is being affected because of this constant exposure to air pollution. Where we may be not exposed for long periods of time because we may be indoors mostly. Well, indoor air pollution is a different matter, but outdoors, you can imagine how long we are outdoors in a day. But these auto rickshaw drivers are, for their livelihood, they are outdoors all the time. And when we inquired about their health, there were some very strong correlations between how many hours they drove and what are some of the medications that they are taking, etc. So very, very interesting research. However, it tells us that the situation is very acute and needs a lot of interventions. That moves us along to the electric vehicle scenario. They have now been around for a long period of time. Back in the day, in the early 20th century, we used to have a lot of electric vehicles as well, because at that point in time, we had electric street cars, etc. It was, motor vehicle, ICE engines were not yet invented, so it was all electricity. But post World Wars, World War I and World War II especially, you see a lot of cars then being coming into the economy of various countries, and that's where the industrialization happened, and motorization also took off. And now we are again circling back to coming to electric vehicles, where we are now concentrating on electric personal vehicles a whole lot. And you'll see that various countries are at various stages of electrification in the world. Of course, China is leading. Some of the Nordic countries, Scandinavian countries also have a very good levels of electrification. But India is lagging behind a little bit. We have our ambitious targets of 30% sales by 2030 is our target. We are yet to get there because there are many hurdles that we have to get past. Why is it needed? Of course, energy security is a big thing worldwide, as we see that there is continuous turmoil in the world because of energy requirements. So hence, electric vehicles is a necessity to move away from fossil fuels, to support clean electricity, lower emissions, improve citizens' quality of life, and to establish a policy of robust market. So we are still building up in our country the infrastructure that is required to support electric vehicles. That is ongoing. Pros are pretty much self-evident, whereas there are some of the cons that are hindering the uptake of electric vehicles in India. Many people have what is called range anxiety. They are always anxious that we don't have enough charging stations on the road. So what will happen if my electric vehicle runs out of charge? So that is something that people are very, very worried about all the time. Recharge can take a while. What do I do? So again, if you take the example of a auto rickshaw driver, currently if his petrol is over, goes to a petrol pump and petrol is refilled in 2 minutes. Whereas if he had a battery, how long will the battery take to recharge is a question that depends upon whether you have a fast charger, slow charger at the battery station. Do you have swappable batteries or not? What is the wait time? Are you in a queue to get these battery charged? Does your home have enough infrastructure that you can charge at home? So all of this is something that is causing a lot of anxiety amongst the users in India. Batteries were initially very expensive. Even today, batteries are, if you look at an electric four-wheeler, electric car, batteries, a large proportion of the cost goes into batteries. Right, so there you are now seeing many car manufacturers, taking the cost of battery away, and they're saying that, well, we will sell you the car without the battery, and you can, rent the battery and use it as you go. So it's there are different kinds of financial models that are being tried to entice people to purchase electric vehicles. From the point of view of to reduce the expensive battery replacements in case of electric vehicles. Charging station availability we discussed, and of course there are the amount of choices that you have for your ICE vehicles you do not have for your EVs yet. A single model or 2 or 3 models from one company, whereas the same company may have 10 models of their traditional ICE vehicles. So all of this is still kind of, I wouldn't say con, but they are kind of, hindering the uptake of electric vehicles in our cities. One of the things you do have to keep in mind, though, that an electric four-wheeler takes up the same amount of space that an ICE vehicle would take on the street. So in terms of congestion, there is a question mark as to whether there will be any reduction in congestion because of an electric four-wheeler replacing an ICEV four-wheeler. We are not seeing many compact electric vehicles come up. We are seeing the size of the vehicles being almost similar to the size of the ICEV vehicles. So that is something that has to be looked into, because while we are tackling the problem of emissions or tailpipe emissions by introducing electric vehicles, we are not really solving the problem of congestion, which is a problem of space and space requirements in our urban areas. So that needs to be also looked into. Electric vehicles. The other point of electric vehicles is there are various types of electric vehicles that are out there that are being used in different countries. There are plug-in hybrid electric vehicles. There are pure electric vehicles, but there are, and what India is heavily investing in is the battery operated electric vehicles, the BEVs. There is some talk now that BEVs are taking a lot of time to come up, or the sales are not picking up. So maybe there is some opportunity to look at plug-in hybrid electric vehicles, hybrid electric vehicles as well. So we'll have to see how far the policy can be tweaked in that regard. One of the important things, however, to remember, and we'll also look at this because through the lens of a study that we did, is to remember that charging still is not green. Charging of electric vehicles is still not green. We are still dependent on charging stations that are providing electricity through coal, and hence to completely decarbonize, we have to also look at renewable sources of energy to be used at the charging stations themselves. So that is one of the things that government policies are also looking at, how to make the entire life cycle green as well. Remember, in order to manufacture, we are not looking at other life cycle parts of or other life cycle elements of an electric vehicle, because if you start looking at how much energy does it require to manufacture an electric vehicle, and that energy and what is the source of that energy, you'll also again see that probably the energy source is non-renewable. So there is a lot of work that requires to be done, a lot of research that needs to be done, but at least we are starting with the lowest hanging fruit, which is to minimize the tailpipe emissions coming out, of the tailpipe of the vehicles by electrifying them first. Here you will see many of the schemes that are being put forth by the central government in India. In addition to that, many of the state governments have their own schemes as well. Remember, transport is a state as well as a central subject, so it's on the concurrent list of the Constitution. So even the states have various schemes that allow you to purchase an electric vehicle, get subsidy on it, etc., etc. At the same time, the number of vehicles, electric vehicles sold is not that much or not that high. Even today, it has picked up. It has picked up a lot after COVID, especially. There has been a marked increase in especially electric three-wheeler sales. Our auto rickshaw, the auto rickshaw version of electric auto rickshaws, that has seen a marked increase, and so has the electric two-wheeler segment. However, the electric four-wheeler segment is still sluggish, and one of the segments that needs a great push is the electric public transport sector. Not many cities are invested in buying electric buses yet. Some of the large metropolitan cities have, but not all of the tier 1 or tier 2 cities have invested in that. and that is something that needs to be looked into. Types of electric vehicles, like I briefly said, there are hybrid electric vehicles, there are plug-in hybrid electric vehicles, and battery electric vehicles. We are currently looking exclusively at battery electric vehicles, whereas there is some talk at the policy level to also look at hybrid electric vehicles, but that needs to be further deliberated. You'll see that this is the electric three-wheeler that has becoming very popular in some of the smaller towns. They are supposed to be paratransit, but of course, we know in Indian cities which do not have good public transport, they are almost acting like public transport, right? They take people from door to door and are kind of very popular. However, the registration of these vehicles and the speed of these vehicles have to be, regulated. Speed in the sense, since they are low-speed vehicles, on which roads that they can ply is something that needs to be regulated. And also in many of the cities, the registration of these vehicles do not need to be registered because they are so low speed. They can get by without getting registered on the in the RTO. So that is also causing some heartburn and problems to many people, which needs to be looked into legally through the Motor Vehicles Act. Many of the other cities worldwide are use these kind of scooties or scooters, they call them. We call these scooties. We have not yet ventured into these kind of electric scooties, but buses is something that we should definitely look at electrifying. Some of the key drivers, like I said, are how to address range anxiety, how to reduce the charging times, and lack of suitable electric vehicle supply equipment. Currently people are also worried that if my electric vehicle breaks down, not just because of lack of a charge, but any other kind of electrical or electromechanical issue comes on the roadside, what is going to happen? Where are the service stations? Who is going to provide me service? Do I have to take it to the dealership every time there is an issue? That will cause a huge bottleneck at the dealership. Are there not enough skilled people who can open up workshops where electric vehicles can be serviced, etc.? So that is also something that is a policy issue that is being debated and looked at. So this is again one of the studies that we did, which was funded by, I think this study was funded by ICSSR, where we were looking at how electric vehicle is being perceived by the consumer themselves. So this study was done way back in 2019, pre-COVID, and we were at that point in time trying to examine who are the people who are likely to purchase an electric vehicle, because we were seeing the electric vehicle purchase was not picking up pace. Government schemes, even though subsidies were being granted, people were not buying electric vehicles. So we were kind of looking at what is the perception of people, what do they want, why are they not, looking to purchase or having an electric vehicle at all. So you would see that, I own an electric vehicle. There are very, very low percentage of people who said that they own an electric vehicle. Even almost a lot of, 13% people say that I have no interest in electric vehicles. But majority kept on saying I have some interest in electric vehicles, but today's electric vehicles don't meet my needs. There is a lot of people who believe that electric vehicles have not reached a certain threshold that makes them trustworthy or something like that. People need to have trust in brands. People need to have trust in in the companies before which they do not usually buy. So there were a lot of people when we asked them, when are you likely to buy? When do you plan to purchase an electric vehicle? Even when we asked them that, majority of the people would say they would push it to the next 5 years, 1 to 5 years, or even a major 40% of them would say they are not sure that they will ever buy an electric car. So this was an electric car. So electric cars face a lot of problems because they were very, very expensive. They were very expensive than compared to the comparable model of ICE car. So people were not willing to pay that additional amount, even though they were very much aware that they are environmentally good, but the pricing was just not good enough. We did again a lot of questions were asked. Basically, we were trying to do a choice modeling exercise to understand which are the factors that are driving their need and which are the factors that are inhibiting them from owning a electric two-wheeler or a four-wheeler. Many things came out. Many people were they wanted cheaper insurance. They didn't know what type of insurance would be available for electric four-wheelers or electric two-wheelers. They all agreed that they are environmentally friendly, but they all also knew that range was very important. How long will a vehicle last? Will it last the entire day? If I go out of station, will it last till I reach my destination, etc., etc. So there was a lot of encouraging as well as discouraging factors. These were the discouraging factors at that point in time. Remember, this was back in 2019. Many people did not like the style, design, and size, for example. Now you're talking about a new type of vehicle. So people are worried. If you make a lot of investment, they would like, although the style design may seem to be very superficial, but as we know that people do pay a lot of attention to that as well. And why is it important? I mean, why is it important to even understand people's perception? Is that the situation was such that despite being offered a lot of incentives, there was still no sales. So hence, it was not the problem of the supply of incentives. It was just that there was no demand. People were not demanding for electric vehicles, despite knowing that they are going to be environmentally friendly. So that really caused us to try to understand the user's perspective as to why should we, as to what is holding them back from purchasing an electric vehicle. We developed discrete choice models in order to understand, why they are likely to choose an electric vehicle or an ICE vehicle over each other. The models, again, these are all published material, but if I can quickly say that we did it for 4 different cities. I think Delhi was the city we compared these 3 cities against. So Delhi always had the highest, people in Delhi were the most likely to adopt electric 2 and 4 wheelers, possibly because there is a lot of awareness in Delhi, because any of the schemes that used to come out would come out in Delhi first, being the capital of the country. And then, we saw that Mumbai, Bangalore, and this was an ordered logic model, which means, the question was, when are you likely to purchase an electric vehicle? And it was on an ordered scale, 1 year from today, 2 years from today, 3 years from today, so on and so forth. So, Mumbai was the one that was second on the list, followed by Bangalore, and Kolkata said that people in Kolkata said that we would purchase it only after a long period of time. They were not ready to purchase it at the same time, or ready to purchase it within the year. So what that also tells us is that there's a lot of variability within the country. We cannot have policies even at a metropolitan level, we cannot say that all 4 metropolitan cities are thinking in the same way. Even within metropolitan cities, there is variability. And of course, when we are now trying to replicate this study in tier 2, tier 3 cities, we are also initially now again witnessing that their demand levels or their demand patterns are even different from what people want in metropolitan areas. Similarly, you can imagine that there would have been differences based on age group, who would like to own an electric vehicle, based on household income, based on the type of housing you have. Now, this was something very, very interesting, because households with 4-wheeler parking were likely to purchase it much earlier, likely to purchase an electric vehicle, electric 4-wheeler much earlier as compared to households without 4-wheeler parking. Because if you don't have a designated parking spot in your house, then you don't know how you can charge your vehicle at your home. If you have a designated parking spot, then at least you are assured that at night or at any time during the day, you can come and recharge your vehicle. So that played a very important part. There were follow-ups that we did with housing societies to see if there were any changes being brought about in some of the housing societies as per parking regulations, etc. So that is something that needs to also change in the building bylaws if electric vehicles are to be encouraged. So you see the factors are very varied. Not just depends. It does not just depend upon the characteristics of the electric vehicle, such as speed, range, cost, and all. It also depends upon, for example, what kind of house you own, whether it has parking or not, etc., etc. So again, I'm not going through the entire model. You can read through the paper, but the point here is demand of electric 4-wheelers and 2-wheelers. So these are 2 different models, 4-wheelers and 2-wheelers. They are different from each other, and they are also different for different metropolitan cities. So when you are developing a policy, you have to develop a policy differently for 2-wheelers for a particular city, differently for 4-wheelers for a different city. So it has to be that granular in order to entice people to purchase an electric vehicle. The last thing we did there was to kind of understand when a shift is happening, or to what extent the shift can happen. In a mean scenario, as an average scenario, what we saw was by 2030, 1/3 of the population was willing to shift to an electric 4-wheeler, and large proportion, almost 2/3 or more than 2/3 of the people were willing to shift to an electric 2-wheeler or own an electric 2-wheeler. I wouldn't say shift. I mean shift as in they would purchase an electric 2-wheeler. Many of them already have a regular 2-wheeler at home. So how much they would use is again a different question. They may purchase the electric 2-wheeler and use it for shorter distances. What we also found in the study later on was, because they were anxious about the range, they would use it for shorter trips to market and to bank or so on and so forth, and not try to make longer trips using the 2-wheelers. They would then depend on the regular 2-wheeler, the households that have 2 vehicles. So those were some kind of nuances that were found out. Just a glimpse into what we are trying to do now is to kind of develop certain applications for people who do not have an electric vehicle and have a regular vehicle, in order to understand if they would like to shift to a different type of mode for their commuting purposes, given the pollution that they are exposed to, or given the pollutants that they are exposed to during their trip. Right? currently what usually happens is you give an origin destination to Google and it gives you the shortest time, or sometimes if you are in a metropolitan area, it also gives you public transport time versus driving time, etc., etc. But it does not tell you what is the exposure that you are likely to face when you are traveling from those two destinations. Newer ones, for some of the cities, now you are able to see the energy consumption that is likely to happen when you drive. But what we are also trying to find is what is the exposure, what is the pollutant exposure that is likely you are likely to face when you are traveling from point A to point B. And if you see that your exposure is high, how willing are you to shift to a different mode, which is more greener mode, or to a different route, which may have lesser pollutants or lesser pollution. So we are trying to, nudge people towards greener modes of transport through the use of application. This is where we are, using a lot of ML techniques to kind of forecast the air quality at a very micro level for say the next 4 hours, or for say the next hour, when because it's all well and good to know what the air quality in the day is going to be tomorrow, but I would rather want to know it when I'm going to be on the road, what is the air quality then, so that maybe I can prepare myself better and reduce my exposure during my trip. So we are looking at developing certain applications that can do that can predict air quality, and that can possibly lead to some shift. Initial results are showing that least air quality pollution, so LEAP routes are least air quality pollution route versus the fastest route. So for example, if you take LEAP route, your travel time is likely to increase by 24% if you are in a car in East Delhi, for example. So this route may not make you reach your destination as quickly as your fastest route, but it may reduce your exposure by 1/3. So this is a trade-off that every individual has to make. That is it okay for me to take a route that will take a little bit longer to reach, but will reduce my exposure by 1/3. So these are trade-offs that we are going to test using this application. How many people make these trade-offs? How many people say that, okay, this is fine? How many say that, no, this is not good. I have to reach on time and I can risk the air pollution, etc., etc. So this is the kind of application that we are trying to develop at this point in time. Also, what we have tried to do is try to calculate life cycle emissions of electric vehicles and say that this kind of scenario should be avoided, right? We should not be thinking that, well, in a diesel car, there is so much pollutant, so I feel dirty. Now that I'm an electric car, I feel so clean. However, the charging is, the emissions is only now being displaced from the vehicle's tailpipe to somewhere in a thermal power plant. So this kind of situation should also be avoided. So we did again a study which was looking at life cycle emissions of electric four-wheelers versus ICE engines, and you can find out that given the energy mix that we have currently in India, we are just about on the good side, on the viability side of introducing electric vehicles. So because we still have over 60% of our energy coming from non-renewable sources, and the amount of electric vehicle penetration that is there makes electric vehicles still viable. But if our energy dependency on non-renewables increases any further, then it doesn't matter how much ever electric vehicle penetration we have, we will eventually not have a complete green mobility mode because we will still be drawing energy for charging from non-renewable sources. So that is one thing that we were able to find, measure. We also looked at, this is the same thing that I just said. We also looked at the energy mix of various countries. And as you can see that, India and China are the two most, along with Indonesia, are the three most countries that still depend a lot on coal, whereas many of the other countries have diversified their energy mixes into different sources. So we have to really look at our energy mix of the three countries here and see that how we can improve our non-renewable sources so that we can truly call, while we electrify or decarbonize the transport sector, we can truly say that the transport sector can be decarbonized. For this, of course, as you can understand, again, like I said, this field is so interdisciplinary that you have to have expertise, different expertise to carry out this research. So this was a prime example where we had collaborated with a professor who has expertise in mechanical engineering, in energy sciences, and they helped us do all the calculations of life cycle emissions, etc. And whereas we were looking at how electric vehicle demand and how electric vehicle usage would affect the emissions. This again talks about, the grid emissions intensity. Again, if you look at India, our emission intensity is not as high as Indonesia's. Indonesia is in a very poor state, but we are still amongst some of the highest intensity of emissions from the grid as well. So that is something we have to look at to make it really green. These are, again, the viability thresholds that I had talked about. We are just, India, Russia, and Japan are marginally in the viable category. Italy, Germany, United States have a significant share of fossil fuel. So United States is also not doing that great, whereas Brazil and France have a very sustainable, viable category because they have their energy mix is very diversified at this stage, and they have. So the introduction of electric vehicles is going to reap them much more benefits, much higher benefits of emission reduction as opposed to the other countries here. Going to even more nitty-gritties of electric vehicles, we have to look at battery technology as well. Lithium-ion seems to be the one that everybody is looking towards because of its lightweight and small size. Weight is one of the more important things, when it comes to its installation in electric vehicles, and eventually when it will come to commercial vehicles as well, because if the batteries get bulkier, it will reduce the efficiency of the vehicle as well. So these are even more minute details that a civil engineer now, who is a transport planner, has to understand, going out of his comfort zone, his or her comfort zone, if you really have to plan to decarbonize the transport sector, right? If you really are interested in reducing emissions on our roads, you cannot just say that, well, I will look at electric vehicles, or I will look at the demand side. I'll look at public transport. I'll look at providing more electric buses, but you also have to look at the technologies that are involved in these electric vehicles, so that they can be, so that you can have a holistic solution to your problems. When it comes to chargers, again, that is another point that comes up all the time in electric vehicles. So, what level of charging should be provided at which locations is something that is very, very important. Everybody wants a DC fast charger, but where is it ideally possible to be located is something that has to be decided. Where can you still get away with having a level 120 volt charger? Where can you move to an intermediate level charger and still, provide enough charge or enough relief to the battery that is discharging at a high rate? This is something also that needs to be looked into. There are basic methodologies that have been developed to locate a public charging station. Locate a public charging, this is not private charging stations. So how do you calculate in your city where the charging stations should be, right? So these are theoretical flow charts and theoretical models have been developed to do this. However, these have to be tested in the field to figure out if the location that finally is being recommended, how important or how feasible that location is, how useful that location is, has to be yet to be identified in the field. Part of government's initiatives, there are a lot of charging stations that are coming up under FAME 2, but they are not anywhere near being enough. We have to have a lot more charging stations that have to be designed or that have to be deployed in the field. This is just an example of the density of charging stations, say, for example, in UK, and the density of charging stations, say, for example, all over India. And even if you look at Bangalore, the spatial density of charging stations is not that much. Maybe it's a couple of years old, maybe it has increased, but the idea is to increase it much further so that the confidence in people improves. Battery as a service, there is a lot of technologies that are out there that are providing good battery as a service solutions. They are, they will manage your monitor and manage your discharging rates. They will even help you swap your batteries at a location of your choice so that you don't have to travel to the charging stations. Somebody can come to your doorstep, say, for example, just like you have Swiggy and Zomato coming to your doorstep to deliver goods the same rate. You can have your batteries delivered to where your current location is. So there are many such solutions that are out there that requires, again, testing, field testing, proof of concepts, viability testing, and all of that, which will make it, eventually adaptable to the common man. So finally, what I would say in conclusion is that, there is electrification has a long way to go. Electrification, however, has to be green. Electrification is not the one-stop solution for everything. For example, there is a big debate on, if what will happen if everybody starts charging their vehicles at the same time when other household appliances also require electricity. So is the peak demand going to be met easily by the grid that is available today? So there are a lot of such debates that are going on, which requires thorough analysis, which requires proof of concepts to be developed so that your city can adopt these services. So there is a long way to go. There is a good work still to be done. In the meantime, we still have to keep up the regime of properly maintaining our vehicles and enforcing the emission norms of the law of the land, so that while we electrify, while we decarbonize our vehicles, we still try to minimize the emissions on the road, and we still don't just wait for electric vehicles 100% absorption into the society, but during the same time we also keep up with our ICE engine vehicles. The second point here is the future of mobility is promises to be shared. Shared economy is something that is coming up in a big way. We have to invest in electric public transportation, which again will help tremendously in reducing the transport's carbon footprint, or the transport sector's carbon footprint. When you electrify a bus, you are reducing the per capita electric usage of transport, because a bus can transport 40, 50 people at the same time. Whereas when you are electrifying a personal vehicle, you are only catering to one person's electrification or decarbonization. So in a bulk, if you're trying to do, trying to reach decarbonization targets, electrifying public transportation is something we should look at, and that will also help reduce congestion on our streets, because public transportation does that. We have to take the EV market vis-a-vis the users into confidence when we are developing new technologies. Technology adoption is a whole field in itself. When any new technology comes, it takes time to gather steam. Right? Think of mobile phone technology. Think of any other new technological developments. Think of your mobile phone back in the day when it started was this huge piece of phone that people could not carry in their pockets. So it was for a long period of time not so slick and not so easy to carry. But over the years, and so that point in time, the penetration amongst the users was very low. People would rather just have if you cannot carry and take a phone outside, you would rather just have a landline phone. It was very similar to a landline phone. So then once technology improved, it became more user friendly, and that's why when we talk about electric vehicles, we have to talk about making them user friendly. That's when the intake will also increase. That's what happened with iPhone and Android later on. The technology, the mobile phone technology, just took off, and now it is everywhere. So if we want technology adoption, we have to understand the EV. Understand the users, understand the market, and fine-tune your product based on the market needs. Battery costs are on the decline, but we have to look at battery technology. That is a matter of sustainability as well, because you are now seeing a situation worldwide where materials for these batteries are being mined from Africa, and they're only available in only certain parts of the world, and that is causing a lot of monopoly or a lot of anxiety amongst many countries as to who will almost control that mining of these materials. So when we think about sustainability, we should also think along those lines, that the use of materials that is required to build these batteries or manufacture these electric vehicles also have to be democratically available throughout the world, so as to not allow them to be stockpiled or allow the costs to rise so much that it benefits only certain sections or certain parts of the country or certain parts of the world. charging infrastructure has to be continuously growing in order to again reduce range anxiety. And lastly, of course, renewable sources of energy is something that unless we move completely towards using renewable sources for charging, using renewable sources for manufacturing, at least majority of the energy requirements come from renewable sources, we will truly not become a green, a green sector when we talk about transport as a whole. So yes, everything cannot be achieved at one go, but incrementally when we try to achieve this, we have to remember the different parts of the pie and eventually put everything together to decarbonize the transport sector. With that, I'll stop here. This, of course, is a result of hard work of many of the students here at the Multimodal Urban Sustainable Transportation Lab at the School of Infrastructure Design and Management at IIT Kharagpur. Many of them have graduated now and are in different places. Many are finishing their PhDs, working in various areas aligned to this, but mostly in, but not mostly, all in the urban transport field. So of course, I am just presenting the work today. It is because of these guys and girls that all this work has been possible. When you think about these presentations, think about these guys. Try to get in touch with them. I think I have somewhere the lab's website is out here, so you can go there. We have all the resources available there. The papers, the journal papers that I was referring to is can be found there as well. If you want to drop me a line, please feel free to do so. My email address is here. And of course, we'd love to host you here at IIT Kharagpur. If I do have, do happen to do a course or short-term course or workshop or anything, I'll definitely reach out to your faculty members, to your research scholars, so that you can visit us. And we look forward to having you here as well. And maybe one of these days I can also visit you guys. It has been a long time that I have not been to Guntur ever since I've left there in 1998, I think, or 1998 was the last time I was in Guntur. So I look forward to meeting you at any venue, and you are all welcome at IIT Kharagpur. Thank you so much. I'll stop here and hopefully let us have some discussion for the next 15-20 minutes.
Yeah, thank you,
thank
sir.
You guys.
Thank you for such a beautiful session. I was like entire time I was stuck, and surprisingly, I happen to be from transportation engineering, although I have did in payment materials, and I've also taken a major help from Amarnath Reddy sir. I'm Amarnath Reddy sir, IIT Kharagpur.
Right.
So it was also on the field of emission, that is a reduction of carbon dioxide emissions from bitumen.
Oh, great. Okay.
We collaborated and we worked. So it was really insightful, and I hope all the participants who have joined us here have gained valuable insights from your talk, and we hope to continue this. As I also belong to the same field, I also want to get in touch with you, and maybe collaborative we can do something. And
sure.
Now I want to request all the participants who have invested all of their valuable times in listening to sir. If you have any queries, if you can raise your hand, maybe we can just turn on the mic for you and you can put on your queries to sir. And I hope sir will be happy to answer the queries.
I see Dr. Saipriya here. Hello, Dr. Saipriya. How are you?
Yes, sir. Hi, sir. I'm good, sir. Thank you for your time, sir, for taking this session. It's very informative and a very wonderful session.
Thank you. Thank you.
Also, I got a special request to all the participants, like as a part of the memory, just I want every one of you who are available now, if you can please turn on your cameras and we can just have a photo, like in this virtual photo. So it's a sincere request to everyone who have joined. Please, if you can turn on the cameras, so that we can at least have a groupie, you can tell, not selfie, it's a groupie together as a part of the memory of the FTP.
Yeah, that will be great.
Yeah.
But you know, the problem with being on camera is you maybe you are in a position not to turn it on.
Yeah, that's what I asked, requested anyone who is like on a position to turn on the camera, please. I'm so glad. I can
So
see.
here are some of our faculties. Dr. Nakiran is one of our faculties.
I cannot see Dr. Vishal.
Good evening, sir. How are you, sir?
Good evening. Good evening. How are you? Good to meet you, sir.
Your presentation is so good, sir. Actually, we got a lot of information from you. Actually, it is guiding for us to the next level to guide our students, sir. Thank you for this much of input for us, sir.
Sure, sir. I'll be very happy. I'll be very happy to, work with any of your students, collaborate with you as well.
Yes, sir.
We are all looking to, expand as much knowledge as possible, not just to students at IIT, but everywhere else.
Yes, actually, this is very happy and privileged time for our students, sir. You are working with our students. It is very good for them only, sir. Thank you, sir. Thank you.
Oh, it's a pleasure for me also.
Yes, sir.
Sir, I don't know about other participants, but actually, I am just curious to ask something. Since I was working on the same field, and you have been monitoring in your campus about these emissions based on some GIS things, whatever. But when I did my PhD, I actually did from MITS under the guidance of Dr. Pavitra Rajvamshi. He's sadly late now. So then I transferred to Muqaddas Ali Ahmed, MA Ahmed. He belongs to this traffic planning. We collected the gas sample, we analyzed the amount of CO2 which is present. So, and then we tried to reduce it with the help of some nanocomposites. And what you are trying to do is the tail end emissions. So, can you suggest us some method apart, because capturing carbon and working, it's a very difficult thing. Can you suggest, or maybe later we can just have a mail conversation or something, and suggest something that how can we count the carbon, like how can we calculate the carbon footprint?
Calculate the carbon footprint. Okay.
Yes.
Yeah, I mean, carbon footprint, for carbon footprint calculation, you really have to go into life cycle assessment to get the real footprint of, any system that you're looking at. What we usually tend to do is the operational life. For the operational life of that system, we try to, calculate, say, for example, during the operations of a transport vehicle, manufacturing, it took us X amount of energy, hence this much carbon dioxide was released. During, fueling, how much fuel, is coming from non-renewable sources, what is its carbon footprint, and so on and so on. But what really, matters is when we start on trying to understand that, while fuel extraction, what is happening, while we are bringing the fuel, while it is being distilled, what is happening, those becomes very, very difficult to capture and, actually calculate. And hence we always say that it's an estimate. We keep on saying that it is an estimate. But it is becoming more very crucial now, because recently what the government is trying to do is now take this carbon credits thing. Okay, this carbon credits to a very decentralized level. They used to give carbon credits to the manufacturers, saying that if you are manufacturing a green, electric vehicle, you can get this much carbon credits as per your, manufacturing norms, and those credits you can again trade in the carbon credit market, and you can get value for it, etc., etc. But now they want it to come to a user level and say that if a person who is driving an electric two-wheeler, how much actually carbon he's reducing, and hence how much credits this person should be given. how much credits this person. So it will all depend on the original carbon footprint of this person. And then after he's driving a green transport, what is the reduction in that carbon footprint? Based on that calculation, they will convert it into credits. And maybe, I mean, this is again a way to entice people to buy electric vehicles, saying that additional, you can make money doing additional things, etc., etc. But yeah, I mean, carbon capture calculation or carbon credit, eventually carbon credit calculation will become very, very important.
Yes, sir. Actually, just recently, although it was not carbon related thing, I just recently communicated a paper to this International Journal of Pavement Engineering, which is currently under review for multi-stage failure of the roads, like especially fatigue and rutting. And I wanted to incorporate this carbon aspect on also, because at the time of construction phase, like what I have done is I have done it in a multi-phase construction, road operation phase and all. So at the road construction phase also, apart from the equipments which are being used in the road construction, the bitumen is also emitting a huge quantity of CO2, because mostly it is constituted of carbon only. In that context, sir, I would be glad if you allow me to have further discussions with you. Where
sure. Yeah. Concrete roads in that case, in that point of view, is very notorious for carbon, emissions.
Yeah.
So,
rigid pavements.
Yeah, rigid pavements are very notorious. Yeah.
Okay, sir. Any of the participants, if you can raise hands, or else
I request all the participants to on the camera. Actually, we give access to everyone. Please, if you want to ask a question, also you can unmute and ask.
That's all.
Okay.
It should be interactive session. Then only we come to know the session.
Yeah. I know it is afternoon, so everybody must be tired, but still.
You've given a high enthusiasm to everyone, sir. We are not in a tired mode. Actually, we are interested to hear your words. The continuous of flows.
I did not move from the seat. Only for a short bio break I went. Apart from that, I was stuck in my chair. Because it is based on my entire PhD on this is carbon dioxide from bitumen.
Yeah. Yeah, I think more and more people should be, we are at least paying a lot of focus now on safety. So transport and safety is getting a lot of focus. So maybe the next, focus would be on transport and environment. And in that way, there is, otherwise environment gets its due share of, research, where we are looking at recycling, circular economy and all of that. But somehow transport and emissions is, we are all dependent on electric vehicle ho jayega, so everything will be fine. So we will start why to do research on electric.
But still there is a good amount of people, like number of people who are doing this research on this.
Yeah.
Okay, I would request Sai Priya madam to just conclude, or I requested all the participants, madam, but I see nobody is turning up. Very sad. I wanted to take a.
Sir. Yes, sir. You can conclude the meeting, sir. You can conclude the session. Yes.
Okay. Thank you. First of all, I would like to thank the management of Madanapalli Institute of Technology and Science for allowing us to conduct this at FDP. And I would like to thank the Department of Civil Engineering of MITS for conducting such a beautiful activity. The coordinators of the FDP, Dr. Nakira, Dr. Saipri, and Dr. Vishal Singh Rawat, for actively doing the background work and connecting to all the distinguished speakers like you. The head of the department, the principal, the vice chancellor of this institute, and all the participants who have joined and who have listened to sir, and lastly to Goswami sir for enlightening us with such a crucial and alarming topic which really needs to be addressed. And it was really glad to hear from you, sir, and we would like to have you in a person, not in face to face at our campus, and we like our students as well as all the faculties to interact with you live. thank you for giving your time from your busy schedule. We are really thankful to you, sir.
Thank you so much. And like I said, I hope this is just the beginning. We will definitely stay in touch, and
Definitely.
I look forward to meeting everyone in person somewhere. We'll also try to invite you guys here.
Sure, sir. We'll be glad.
Thank you, sir.
Thank you.
Thank you for giving your time, and we'll be waiting for that opportunity where you invite us to IIT Kharagpur, sir.
Okay.
Thank you, sir. Thank you so much.
All right. Thank you so much.
Thank you, sir.
Thank
Have a
you.
good day.
Bye.
Bye.
Thanks.